We are going to be talking about applying engineering principles to reporting. Quite a weird topic, reports as an output. Yeah. I want you to imagine you're in this F1 car, and it's a car that's designed for high performance, for agility, for speed, and you can spot all the AI flaws in my AI generated image. But with this high performing car, cruising along on the highway, you're doing good progress, hitting all your milestones, things are going well. And then next slide, thank you. We hit a toll booth and you bring this high performing F1 team to an absolute halt. And it's so bad that the toll booth isn't even automated. It's a manual toll booth. The poor guy's got to figure out change and all this nonsense. So this is what's happened to us in our team. Thanks, G. We design our teams for speed and agility, but a single toll gate can bring that entire team to an absolute halt and stop all progress. So, morning, everybody. I am Shaun. I'm head of consulting from the Johannesburg office. And then with me here today, we are three presenters. I've got Dan, quality engineer on our team, originally from Australia, now in England, and Guillaume G, originally from French Caribbean, also based in Johannesburg with me. So we're going to take you on a little bit of a journey today of just an intro into our team and what our team actually did in the data space, the problem that the client presented us with, that toll booth, go into some fascinating discovery process of how we discovered and unpacked this issue and the very complex stuff we found. I'm going to talk a little bit about our ways of working, then as a team, how we structured ourselves to solve this problem. And then G's going to go into the nice technical stuff where we shift left to get quality reporting data and shifting right to automate as much as possible. And then the last slide, some really awesome results and outcomes that I can show you. So yeah, I'll hand over to G.
Cool. Morning, everyone. So I'm going to tell you a bit of context. So we work in data engineering. So one thing that we build is data pipelines. So we ingest data from suppliers. We need to make sure that it's done securely and reliably and efficiently. So the data arrive, we land it into a row shape, and then we run through a bunch of process to clean the data, refine it, and get it to a state where it's easy to consume. So in some cases, we send data back to external consumers. And in other cases, our data pipelines push data to an analytics, data science, and reporting team. So a core thing of what we do that is data governance. So we need to make sure the data is cataloged and classified so that it's easy to find. And also it's consumable by people that have sufficient rights to do so. So PI data, for example, is very important. GDPR regulation is very, very important. So while we do that, we also build our data pipelines using other pipelines. So in this case, we have a picture of a GitLab job. So we're quite lucky to operate within an environment where we have a mature platform team and a payroll team. They give us lots of reusable building blocks. But I just want to put this slide here to highlight that a lot of what we do is highly automated. So we have automated steps to do stuff like linting to ensure the code is consistent. We do stuff like unit testing to make sure the business logic is sound. And we do infrastructure as code to ensure that your cloud resources are correctly managed. And the whole thing that ties it together is really we use a tool like Jira to track the work. So everything that we do is visible, tracked, and auditable. And we tend to release in small batches very often. So this goes back to the title of the talk, which is about engineering principles. So those are the principles that we follow when we work on a daily basis. So let's zoom out a little bit, and we're going to talk about reporting at a very high level. So our client uses Snowflake, which is a cloud data warehouse. So it's like a big warehouse that contains the data, and they build reports using Tableau. And at a very high level, a report looks at something called a data source, which is basically an abstraction for the data that resides in the warehouse. And the big change that happened to us at about 2 years ago is the client said that all the standing teams, so the data teams, had to take ownership of the data sources. So basically, we had to find out what Tableau was about. We have to upskill in Tableau. And the second challenge for us is we come across very different ways of working, which is basically why we're here today to give the talk to show you what we've learned.
Alrighty, so different ways of working. So as G said, we took ownership of the Tableau data source, or at least we'd been asked to take ownership, and we launched into a discovery. And like G said, we brushed up against some very, very different ways of working. But to begin, I'm going to talk a little bit about our history. I think this might be a common pattern in the industry, but on the client, Tableau was chosen as the analytics platform around 3 years ago, I think, thereabouts. And when they did that, they sort of opened it up to everyone in the business. They said, bring your data from your spreadsheets, bring the charts from your spreadsheets. Let's get it in a centralized platform. And so we could start building our dashboards and sharing our dashboards and data and all that jazz. Really good. Lots of enthusiasm in doing this. Everyone got involved. So we saw this rapid explosion of dashboards in Tableau, which sort of at the time it was good as far as a tangible business value. Blah blah blah. I'm skipping through these steps, but the point is, it was a good start. That's what I wanted to end with. The Tableau team, who are the team that we interacted with most throughout this process, they noticed that over time they were really struggling to keep the quality of the Tableau data sources and the dashboards high. So they saw a notable dip in the quality. Some of the issues they had identified was lack of ownership and skills. So what you'd often see is you'd see some champions who knew how to build good Tableau data sources, knew how to build good dashboards. They'd solve a problem for one business function, and then they'd move on very quickly to the next one, and then the next one again, and leaving sort of a trail of Tableau assets behind them that are sort of unmaintained and not changing. So that skills imbalance was that you had champions that would run towards problems and solve them, but then you had maybe those Tableau data sources and dashboards would fall into disrepair over time. The other thing they called out was that the asset owners would sometimes sidestep certifications. So that Tableau team I talked about was centralized. So they had a certification process that meant that all changes that were certified needed to go through them. So you ended up with quite a backlog of changes that needed to be certified. So some of the asset owners would then, find shortcuts, find ways of sort of deploying a model into Snowflake. G's going to talk a little bit more about this. But also another pattern we observed was that we'd see calculated fields, so a lot of logic creeping into the Tableau data source. And it's not the easiest thing to test as well. And again, G's gonna touch on that a bit later. So ultimately, we had a bit of broken trust in the quality of the data. To summarize all of that, go on, jump in.
You say certification.
Yeah.
Like, what is that?
So that's so you have sandboxes, and then you have like a certified dashboard and Tableau data source. So the sandbox would be where you sort of realize the value of data underlying by building up something that perhaps isn't in production yet. And the certification would be, is this discoverable? Does this have a good description? Is it showing, is it showing insights that are actually true? There's a degree of QA and whatnot that needs to happen on anything that gets pushed to certified.
And also the data was being used for business decisions. So certification, like, put a stamp onto the data to say this is good data, the formulas are correct. We're all talking the common language. Early on we found there were teams that were calculating percentage net profit differently, and they were all using different calculations. So the certification process helps us standardize on that, so that when business decisions are made, they are using the correct data. Yeah.
Yeah, so it was a centralized Tableau team, but what they decided, so they were struggling at governance scale. We saw a dip in quality of Tableau assets. So their solution was to decentralize governance, and they came up with this center of excellence. And to support that center of excellence, they came up with quite a complex change request flow diagram, which was backed by loads of documentation on how to go about managing and releasing and maintaining your Tableau assets. This is all AI. This isn't like true representation of what they produced. Yeah. We didn't use any AI in this whole thing, but except for the slide deck, lots of AI. So yeah, they came up, which is great actually, because they managed to, I guess, write down their problem, write down what it is we need in order to keep the quality of these assets up. But yeah, I guess there were some challenges. So we had lengthy feedback loops in that flow diagram. We could see where we were meant to step in this long process flow. And we could see lengthy feedback loops. We could see that we would need to interact with people within the business that maybe don't get back particularly quickly. We'd interacted with them before. There was a very long 17-step verification checklist that needed to be done by a certified verifier, I think. So it had to be done with someone who, again, introduced another bottleneck. We had missing actors in the process, which is even worse than people who don't get back to you. And we had late stage quality checks. So the upfront thinking about how we were going to test any Tableau data source or Tableau data source from our perspective, that upfront thinking really wasn't there. So we ended up, so you'd end up just doing a bunch of rework because it didn't meet the business need. So to summarize all that, the CR process complexity threatened to slow our delivery, but we'd identified several areas for improvement. And that's where I hand over to you, Shaun.
Thank you. So our approach then as a team after discovering all this was, number one, collaborative partnership. So we started working very closely with the Tableau Center of Excellence team. They weren't well versed in agile principles. It was everything, as you can, it was very manual driven, checklist driven. And they didn't understand the concept of continuous delivery, of reports. That the collaborative partnership, education on the agile principles, that was actually very cool. We had a great team of people that we could work with and were receptive to listening to how our team could work. Breaking things into smaller batches, clear definition of ready with the UAT requirements. And then the key takeaway here was just regular communication. We set up these fantastic cadences. We had like twice a week we would check in with the team, and I've got a great Google sheet if anyone wants it that we used to track the initiatives and the feedback with the Tableau team, continually showing them progress. As we were making progress through automating the process, really taking them along on the journey. So to summarize that, next slide. Our approach is focused on building trust through consistent delivery and nurturing strong business and engineering relationships. We're coming from an engineering point of view, and then we're going to tie this up with the business expectation group. So it's cool. Next up is this is where the fun work started. We started transforming the process. So we did work on optimizing the workflow. On the right-hand side there, reducing all these handover points. That 17-step manual process was literally going from almost like person to person, manual checks. Brought in Jira and introduced the Tableau Center of Excellence to working on Jira and a Kanban board and those concepts. Standardizing our checklists, obviously, and then all of this resulting into far faster feedback cycles. So on the next slide, now there's a change. All these improvements were being documented, and now we were feeding it back into the Tableau Center of Excellence, and these became team-owned best practices. All the work we were doing as a team, we were busy uplifting the Tableau Center of Excellence, and they've incorporated this into their documentation now. And from there, they are now distilling it out to all the other data teams, and all other data teams are starting to use these approaches.
Yeah, I think you mentioned it at the start. It's that we were the first team on a platform, I guess, that sort of worked into this. So yeah, everything we were doing, we were thinking, right, if it's saving us time, it's going to save like times 8 or 10 or so. Yeah, nice, Shaun. Alrighty, so the other discovery that happened sort of alongside the ways of working was around tooling. So it's probably, yeah, no, it would be fair to say, I think, I'm looking at David, we didn't really have any Tableau experience within the team. I think people had used other analytics tools before, but I don't think any of us had ever used Tableau. So we sort of walked into this using Tableau the way everyone else in the organization was using it, which was via the UI. And I've kind of redacted and blurred out this particular one to protect people. So this is a Tableau data source as you would see it in the web browser. And I mean, there's a lot of good information here, I guess, but one thing that we noticed is, you can see you've got your heading, you can see who the owner is, you can see connection details and descriptions, but what we couldn't find anywhere was version history or an auditable track of who made the change, when did they make it, and why. That didn't seem to exist in the UI. In addition to that, lineage was incredibly difficult to figure out. So you'd have a Tableau data source. That little blue icon there is the Tableau data source, and you probably can't read it, but that Tableau data source connects to 10 tables and it serves 29 workbooks. But at field level, we have no idea. Like, you would need to jump from table to data source to workbook and just explore each and every one of them in order to figure out where a given field is being used. So that was a bit of a challenge. It's limited value from a lineage point of view. And then the fields themselves. So these were a little painful from a user's point of view, because you could click on a field and then you get a pop-up, which is great, and it would tell you where exactly that particular field was coming from. If it's a calculated field, it might reference other calculated fields. So if you wanted to click through, you couldn't. You would need to go back to the original page, open up another browser, get another pop-up, and another, and another. And it was mental gymnastics to try and really track lineage or to understand what some of these calculated fields were doing. So a real challenge there. And added to that, I think if you end up with a Tableau data source that's over around 300, this is probably a bigger issue, over around 300 fields long, this pane doesn't even really load. So yeah, it's not good. So that was a challenge. Tableau's UI did not provide the engineer's view of the data source. So if we had to maintain this, we just couldn't do it in the web, it felt. So what did we do? We started exploring the RESTful API, which we knew was there, but I don't think we'd really looked closely at it. And very quickly, G will talk more about this a bit later on, but we could see that the Tableau data source was something that we could export as XML, and then we could upload it to a given location as well. So yeah, it had that potential to integrate with our CI/CD pipeline. And there are a bunch of other calls. I think G will talk a little bit more to them later about, aspects of the Tableau data source that you could change, like connection details or labels or data quality checks and whatnot. So that was a win. But the big one was the GraphQL metadata API. We didn't know we loved GraphQL until we found that there was a metadata API, and that lineage challenge that I referred to a few slides back could be solved in code rather than clicking through a UI the way we were. So benefits of this, obviously, we could map lineage at field level. So from now, if we were to remove or change a few fields, we knew that we could see where that data was coming from and where it was being served, in what workbooks it was being served. And that, I guess, that next dot point there about determining the impact of a given change, that pretty much gave us that ability. When we did have a change that came across, we could say exactly what the blast radius is. We knew which sheets may experience some changes, and we could approach the owners of those sheets and work with them to, I guess, ensure that we were testing appropriately. A couple of other use cases we had was assessing the cost of ownership. So we had a Git repo that G created, and we were just sharing queries and whatnot, so it was great. And we could actually, for a given named Tableau data source, we could very quickly pull back all of the fields, whether they were calculated or not. We could see all the data sources that that Tableau data source connected to. Do we own them? Do we know what they are? Who do we need to talk to? We could see all the workbooks and sheets as well that they were serving as well. So we knew the consumers of that data as well. So we could see how much it was actually going to cost to make a call and whether or not we rebuild the thing. That last use case, I'm not going to go too deeply into, but we had a couple of cases where we had to compare forked Tableau data sources. So again, maybe a product of the certification process taking a little bit too long, but you would see a certified Tableau data source get forked and evolve, and then the business would start switching to the uncertified Tableau data source. And then the request was basically, once you guys to merge these, you couldn't do this in the UI at all, but with GraphQL, yeah, we could pull back all the information of both and do a diff and actually start to sift through the carnage to just try and figure out whether or not we were even going to do this, which in some cases we did, and in some cases I think we pushed back. But it was great. GraphQL was a real win. Okay, so this was all in discovery. This was all just, things that we could do. We went back to the Tableau team and we played back our findings, and they loved it. It aligned well with their ambitions. They could see, right, yes, this manual process that we have, there's opportunities there to automate. And yeah, like I said, they saw the potential immediately, and they donned the product owner hat and started laying out feature requests and whatnot. And yeah, that was I guess a good outcome from the discovery to actually bring that team closer to engineering ways of working. You're up, bud.
Yeah. Super Shaun on the TS with the XML side assisted between Chinese.
Yeah. So far, we haven't had a problem. Cool. So I'm going to talk about some of the stuff we've done to ensure the reporting data is sound. So basically, Dan was talked about GraphQL and all the issues we found out. And this is about how we address these issues to make sure the reporting data that the people are using is actually correct. So if I go back to my data pipelines picture, I just want to mention that we use dbt as the data pipeline mechanism. So we create pipelines using code, basically chaining SQL transformation. So one thing which is very nice about this is that it's all written in code, so you can put it into GitLab. Also, it's testable, so you can test each chain of the transformation individually. You can log the input and ensure that the transformation does the right thing. So it's highly testable. You can do TDD even. You can unit test, and very importantly, it's all auditable because it's all in code in GitLab, which means you can track it to a Jira number. So you know exactly what you're doing. So what we found with the GraphQL, we basically found 3 problems. The first one was we had data within Snowflake, which is that red box, that we didn't know where it came from. Okay, so some people had created in the past some tables using some other tables, and the data in red is basically ungoverned, right? It doesn't follow the compliance principle that we follow. So there was no GDPR, there was no classification, so the data was basically a rogue data. The second problem was in the data source, people were doing things that shouldn't really be done in data sources. So do things like computations, and because those things were done in a data source, you can't really test them. It's difficult to version them. And the same problem also happened in reports where people were doing calculations in reports. It's like doing a calculation in Excel, for example. And the issue is we found some serious problems where, for example, there was a business report that people were using in production that was incorrect because it was essentially using dates twice. So instead of showing you average per week, it was average per week and averaged again. So the business was using a so-called trusted report, but the underlying data was incorrect. So most of the work went into finding those issues, and the solution was actually quite straightforward once we have found the issues. So basically, we transformed the red box into a pink box by applying dbt also to that data. So we basically took ownership of the ungoverned data and model it using dbt. So we now have the same good things. Basically, business logic is in code. We have traceability. We have unit test. So now, for example, if you go to a report, the report is now simpler because it doesn't do much, and the data source, it becomes dumb because all it does is to pretty much read from the viz layer. So now we have business logic that is trustworthy, unit tested, and also audited, because every time you make a change, you run the entire pipeline. The change is linked to a Jira ticket, so you know exactly what you're doing. You know who's deploying what, when, and for what reason. So this is what we did essentially to improve the quality of the reporting data. So as we got more into the Tableau work, we discovered all the APIs that Dan mentioned, and we just realized we could apply those APIs to build our own tooling. So we like Shaun said initially, we are a very fast team, and we apply, we build, we run it. So we deploy features I don't know, many times a week. And we also, once those features are deployed, we also operate them, right? And what we wanted to do with Tableau, we wanted to be able to do the same thing. So we wanted to be able to deploy features quickly. We wanted to be able to monitor those things, operate them just like we operate all our data products. So to give you an idea, we have about 20 data products we deploy on a regular basis. And when it came to Tableau, we just realized we couldn't do that because Tableau itself lacked all these tools. So our solution was to essentially build those tools for our need. We initially built them for ourselves, and we're now in the process of making sure those tools are available to other people in engagement. So just to simplify, it's a combination of Python, Tableau API, so it's the REST API and a GraphQL, and some Docker. And basically the Docker is the packaging tool, so it's easy to run in CI/CD on your own machine, or even in something like Airflow. So we've built 4 tools. I'm going to talk about the bottom 3 first briefly, and then expand on the first one. So the audit tool is like a health check for data source. It will check that data source has got some properties set right. So things could be like names, descriptions, tags, simple things. Make sure it's correct. So you can think of that feature as a linting feature to make sure that your code is consistent. But you can also check things like how the data source itself connects to the database. And the reason why it's important is that Tableau has the concept of caching. And if you don't configure your data source correctly, or if you misconfigure it by mistake to a huge query engine, that can cost a lot of money, right? So we were taught at some point that Tableau reporting accounted for half the amount of database usage across the whole engagement. So just making sure that we can use the right query engine for a particular report is very important. So make sure that the report uses just what it needs and not something that is overblown. So that's the audit tool. Then we have this thing called the data quality warning, which is basically an extension of our operability to business users. So we run data quality checks all the time. The data comes in. And if the data, let's say, for example, has got issues or it's arriving late, we have a way to automatically flag that this problem all the way to Tableau. So if you have a business user who's looking at a report, there will be a little icon on the top right saying the data that you're looking at has a problem. Click here for more information. So this data quality warning is a feature of Tableau that we basically automate how it's set and unset. So our tools are constantly monitoring data that arrives, running tests, and if the data has got issues, we flag it. As soon as the data stops having issue, we unflag it. So it's very nice. And the refresher, which is what David worked on, deals with the issue of data which arrives very infrequently. So I was saying earlier, data in Tableau can be cached for performance reasons. So basically, the data refresher deals with the cache invalidation problem, making sure that if there's new fresh data which arrives from our supplier, we can refresh the data source. Again, that's done automatically. Yeah.
So this just proxy, does that mean that there's a button in Tableau that someone can press and it'll trigger your DBT run?
No, it's all done when you run the DBT in Airflow. You talk about the refresher specifically? Yeah, so when the way it works is when the DBT model's transformation runs, then you run a query to detect if the timestamps that you've ingested are different from the timestamp that you've ingested before. And if they are different, then you force a refresh. Yeah, that's how it works. Okay, so let's talk about promotion. Okay, so I just want to briefly talk about the side effects of Tableau, which is a highly UI-centric sort of API user interface or tool. So it's working in Tableau is actually time-consuming because you basically have to go to the UI, use a wizard to drag and drop things, and use a wizard to rename things, and use a wizard to connect things together. So every time you do that, you incur latency, which is even worse in my case because I live in South Africa and the latency was even worse, and so it's quite tricky. And also, it's not easy to validate, because if you want to validate, let's say, a calculation, there's not like formula that you can see that you can't run a unit test against it. You have to basically look at the figures and say, okay, they look right. And as Dan mentioned earlier, there's no concept of audit trail. So if you look at the Tableau interface, you can see something, but you don't really know how it got to be in that state. There's no way of tracking all the changes which were made to Tableau. There's also another problem, which is basically there's no, like, the release pipeline is quite simplistic in Tableau. You just publish something, and we came to realize that people that work in Tableau, they don't really understand the fact that you should have like a non-live and live environment. For them, it's like you write a report or a data source and you connect to a production database. But we like, what if you want to introduce feature in the database that is not yet in live? You want to test it before, and you can't really do that. And the consequence of the lack of release pipeline means the dev work, so people that are doing Tableau dev work, push it to production without doing the proper testing. And the other thing we found is that this weird dynamic between the business wants people to self-serve, right? They go to business users and they say, now you're going to build your own report, you're going to build your own data source, and off you go. And it's all going to work out. But we found that in some cases it works, but self-serve data, data that is made by business people, is not always dependable. Right? So at the end of the year, to get an example, it was a change of the trading period, and we got about four or five reports or data source that failed, and people come to us saying our data is wrong, and we're like, okay, this is financial services data, but we don't own those data sources. Let us find out. And it turns out, people were doing all sorts of stuff in Tableau, and they went on vacation, and then we had to wait for like 2 or 3 weeks for them to come back to fix it. And eventually we took it over. So that's why we were saying, self-serve is not always dependable. So what we did essentially was to fix all the shortcomings. We actually built like a CI/CD tool that allows us to do the things we wanted to do, because we found that Tableau gives you the API to be able to upload, download. So we have this tool called what we call it? I don't know. We haven't settled on a name, but basically it goes to Tableau and you tell it which data source you want to work with. So you can download the source code, and the source code is an XML format. So you can look at it, and if you're brave, you can make changes to it. But once you downloaded it, you can store it in GitLab and have it in source control. And then we have automated steps to basically repoint the same data source to a staging environment and a production environment. And there's one dimension missing on this graph, is basically you can point to a staging Tableau environment using a dev version of Snowflake, or you can do it with staging Tableau using a production Snowflake. So you can do all sorts of combinations. So this is how we solve the CI/CD problem for Tableau, and roughly how it works. So it's a bit like a Terraform-ish. We have one folder per data source. So you download the source code using the tool, and then you have some configuration that's about metadata and tags and names, etc., etc. And you get profiles. So the profiles basically indicates where in Tableau you want to push your stuff to, or where in Snowflake you want to read from or write to. And you can do all sorts of combinations. So for example, you can connect to someone's you can have a service account for production. You can have connect as a user for development purposes. And we really made it simple. So it's like two commands that you can run either locally or in CI/CD or in Airflow. You can download the source code. So you tell it what you want to download, and then you want to publish, and you tell it where you want to publish using what connection. So this allows us to do things like, if there's an issue in the production Tableau data source, we can download it. We can hack the XML or fix it, and then we can push it again to dev, test it in dev using dev Snowflake. Then we're happy, we test again in dev using prod Snowflake, and then when we're happy, we just deploy everything to production. So, but the key thing is, those things are not really possible if you were to use the Tableau UI. And what's important is that those things take seconds instead of, well, we said hours. Maybe hours is a bit too much, but in like minutes, but in terms of like 30 minutes, 40 minutes. So it's like literally a few seconds to do all this. where if you do it by hand, it will take you much longer. Yeah.
When you say profile there, is that analogous to the EVT profile? So
Yeah, exactly, yeah.
profile.
That's correct, yeah. Yeah.
You say name.
Yeah. And you can name them, how you name them is completely arbitrary, up to you, yeah. Yeah, that's it.
Thank you, G. So, I mean, as you can see through these tools, you know, all the tools enabled us to do automation, get through that poll booth quicker. So the audit tool G mentioned, 90% reduction in manual checks. So you see that audit tool run is actually amazing. It's like a very cool checklist that goes through and does an in-depth investigation into that data source. Very, very cool. The data refresher, that Robert worked on, really helped us significantly bring down the cost and compute. So as G mentioned, Tableau's got that caching mechanism. So we were able to update the cache only when needed, not update the cache all the time. Promotion tool helped significantly to just get a CI/CD pipeline running nice and smooth. And then the data quality warnings were very, very cool. That really, the end users loved that because you open up a report and immediately it goes like, the data is late. You don't have data for yesterday yet. So just be aware what you're looking at right now is running a day behind. And then when we do get the data from the third party supplier and it does eventually land, we can automatically take that warning off. So you look at the reports, again, you're looking at fresh data. Yep. So thanks. Oh, yeah, the results were really impressive. A 90% reduction.
How do you know if the point of like how do you know sometimes that there's also so here?
So data is late.
Yeah. So you run DBT checks. We run DBT checks on the data. So whatever fires with DBT checks, DBT test, some of them get propagated to Tableau.
So those would be like freshness warning.
Yeah, we have freshness. We have, the way it works is we tag the test with a special prefix, and then then we have plumbing to run the test, pass the test results, find the tests that have those tags, and then those that have the tags, we find the corresponding assets in Tableau using the GraphQL API, and then we use the REST API to set or unset and set the issues. And we also have a database to track over time, the test failure and recovery.
Yeah. Cool. So you can see manual checks went from like 100% of our time, brought down significantly. Big reduction in our deployment times. And now the ability to scale. Because all of a sudden now, going from manual, now we can scale this across multiple Cs. Cool. We have a case study that's published on the Equal Experts website. So definitely go into more detail on the case study. This is the publicly available version of the case study. Behind the scenes, we do have a internal blogging post as well that does this in a lot more detail. I think we can skip the next slide. We're short on time. Just some lessons learned. I mean, the main thing to call out there was really working with business, automating. Automation is key. Yeah. And at the end of the day, and this is a nice reflection when we put this talk together, it was really nice for us as a team to collaborate with smart, approachable, and eager to learn colleagues, because that made the whole experience just better. And by colleagues, I mean it's the entire team, it's the client team, our team, and everyone. It was a very cool experience. Cool. Thank you, everybody. Boy. Cool.